Welcome to our first set of fluid mechanics practice questions. In this video, we will dive into fluid properties. Ensure you are referencing the FE handbook while answering these questions. As a supplement to this course, check out the full-length practice exams and other topic-specific practice questions that can be accessed through the link in the description. These practice exams are the best way to prepare yourself to take the actual FE exam. Moving on, let's get started with some fluid mechanics practice questions. Practice question 1. A sealed tank contains oil with a density of 850 kilograms per cubic meter. The depth of the oil is 3.5 meters. The local atmospheric pressure is 101,325 pascals. What is the absolute pressure at the bottom of the tank? We begin by recognizing that absolute pressure is the sum of atmospheric pressure and the pressure exerted by the fluid column above the point in question. That fluid pressure is determined using the product of density, gravity, and depth. In step 2, we plug in the known values. Using these givens, we compute the gauge pressure from the fluid column, which turns out to be 29,157.75 pascals. In step 3, we add the atmospheric pressure and the computed fluid pressure. This gives us a total of 130,482.75 pascals. So, the correct response is choice A. Practice question 2. A thick, non-Newtonian fluid flows between two parallel plates in a manufacturing process. Laboratory testing shows that the fluid has a consistency index of 0.25 and a power law index of 1.5. If the velocity gradient between the plates is measured to be 8, what is the resulting shear stress in the fluid? We begin by identifying the relevant quantities given in the problem statement. Next, we use the power law expression for shear stress in non-Newtonian fluids, which states that shear stress is equal to the consistency index multiplied by the velocity gradient raised to the power of the power law index. Substituting the given values into this formula, we have 0.25 times 8 raised to the 1.5 power. Evaluating the exponent, we get approximately 22.63. Multiplying by the consistency index gives us a final shear stress of approximately 5.66 pascals. Thus, the correct answer is option A. Practice question 3. A soap film is held in a wire with a total contact length of 0.30 meters. If the force exerted by the surface tension along the interface is 0.018 newtons, what is the surface tension of the film? We first identify that the general equation for surface tension should be used. We then plug in the known values. The force is 0.018 newtons and the contact length is 0.30 meters. Finally, we get a surface tension of 0.06 newtons per meter. Therefore, the final answer is option B. Practice question 4. A liquid has a specific gravity of 1.75. Given that the specific weight of water is 9,810, what is the specific weight of the liquid? We begin by identifying the formula that relates these two quantities. The specific weight of a fluid is equal to its specific gravity multiplied by the specific weight of water. This relationship comes directly from the definition of specific gravity. Next, we substitute the known values. The specific gravity is 1.75, and the specific weight of water is 9,810 newtons per cubic meter. Multiplying these two together gives 17,167 newtons per cubic meter when rounded to the nearest answer option. This matches answer choice D. Practice question 5. Which of the following statements is always true about the relationship between density and specific volume of a substance? The first step is to recall the definition of specific volume. Specific volume is defined as the volume per unit mass of a substance. Mathematically, it is the reciprocal of density. We can then interpret this relationship using the definition. If we have an equation where specific volume equals 1 divided by density, then it's clear that as one increases, the other must decrease. This confirms the inverse nature of the relationship. Finally, we evaluate the given answer choices one by one. Option A incorrectly states that a higher density means a higher specific volume, which contradicts the inverse relationship. Option B also incorrectly claims a direct proportionality. Option D is false because while density increases with pressure, specific volume actually decreases. Option C, however, directly states the correct relationship. Specific volume is the reciprocal of density. Therefore, the correct answer is option C. Practice question 6. A small diameter glass tube is vertically inserted into a container of liquid. Due to capillary action, the liquid rises within the tube. The height of the rise depends on fluid properties and tube geometry. Which of the following changes would result in a greater capillary rise? We begin by identifying the underlying equation that governs the physical behavior. The height to which a fluid rises in a capillary tube depends on a balance between surface forces and gravitational forces. This height is expressed in terms of 4 variables: surface tension, contact angle, specific weight, and the diameter of the capillary tube. We can then analyze how each variable affects the height. If the surface tension increases, it drives a greater upward force at the interface, which increases the height. A smaller contact angle increases the cosine term, which also boosts the numerator, raising the height. On the other hand, a larger specific weight means the fluid is heavier, which increases the downward force and thus decreases the height. Similarly, a wider tube increases the diameter, making it harder for surface tension to pull the fluid upward, which also reduces the height. Finally, we evaluate each answer choice. Option A, increasing the tube diameter, increases the denominator, reducing height, so that's incorrect. Option B, decreasing the surface tension, lowers the numerator, again, that decreases the height, so also incorrect. Option C, a smaller contact angle increases the cosine value and therefore increases the capillary rise. This is the correct choice. Lastly, option D, increasing the specific weight, increases the denominator and decreases the height, so that is also incorrect. Therefore, the only correct answer is option C. That concludes our practice questions for this unit in fluid mechanics. In the next lecture, we will continue with fluid mechanics and cover topics under fluid statics. Again, if you want more example questions or complete FE practice tests, visit the link in the description or on screen. Thanks for watching.